Hey everyone, so continuing our discussion about system design foundation course. So this is the diagram that you are probably aware if you're watching this video from the first one from the playlist. If you're directly coming to this one, I highly suggest you that you go through the playlist and watch the first video and come to this one. You will get the complete understanding about this. So we have seen in here different layers. This is the client layer, this is the API gateway, this is the web server and private instances layer, and finally we have this database layer. This database, you can see many things in place. All of these things I have explained in the previous video in very much detail, so go ahead and watch this one. So what is the topic for this video? In this one we are going to see the role of cache. How cache plays an important role in having a very good user experience while interacting with our services. So the cache can be of different kinds: single server cache, in-memory cache, or distributed cache. So first we are going to understand the need of the cache, then we will discuss each of these one by one. So let's consider a user flow, a request flow from the client side in here, and see how the request travels throughout the system. So let's say I'm a builder, I'm trying to register my property. So as a client, I will request that from my mobile or browser. That request will go to the API gateway, that will go to the load balancer, one of the load balancer, and then we will have specific functionality on the server side. And after validating that request, it will interact with the database. It will write the data to the database and replicate it to the read databases as applicable. And when all of this is successful, it will revert back the responses, and ultimately I'll get the success response, whatever I have requested. Okay, so in this flow of request, you will see from left to right, the database operation is the thing that is pretty much costly. So by the time the data is being collected in the database, and by the time it will grow in size, right? So if I have to write something, so there will be database constraints will be there. I have to follow that and write that data to the database. The similar flow, similar rules apply while we are reading the data from the database. When reading the databases, I have to search that data in huge pile of the request, that is there, like millions and billions of records are there, and I have to look for the one single record or list of records from there. So you can see, and by the time there is a high chance that huge amount of data that is not very much active, only some of them are active. So how cache plays role in here, right? It is based on the concept that whatever frequently used data is there, keep that close to the server where it is needed. Okay, so this is a very big diagram, so let me simplify it and put one more diagram in here. Okay, so let's say this is a web server. This is our web server, and we have database connected with this one. For simplicity, I am drawing this one. So this is the DB where I have all the data write and read requests coming through. All right, so let me expand it a bit so that it's more visible to you guys. Okay, so all the interaction is happening in here, web server and database, and if I, for each and every record, if I hit the database, that will be costly operation. So whatever useful thing is there, so I will put it in here. So temporary storage. Why am I saying this as a temporary storage? Because I am not going to have all the data in here. The permanent storage is with this one. This is going to be working as a temporary storage. Temporary storage, all the active records will be there. How we say that it is an active record? Maybe I can say that last 10 days record should be there in this database. Otherwise, clean that automatically. Clean up the data that is older than 10 days automatically. Or I can say that whatever data that is frequently accessed from the database, keep that data only in here. So how the request flows now, whenever any read request coming in, so instead of hitting directly to the database, this request will check in the temporary storage. If this is available, the response will be written directly from here to the web server. If this information is not available, it will go to the database, get the data. This will respond to the temporary storage in here. It will store that information in this temporary storage and then will go back to the web server. So you see, initially when there is a cache hit, when the data is found in this temporary storage, that we say that data is hit, cache hit is there. So that will be returned from in this temporary storage, or if now we know the terminology, so let's name it cache here. So the data will be returned from here only. So but if that data is not available there, that's what we say that cache miss case is there. I'm just changing this color. So if the request has come to this one, this, so that it's properly visually correct. So requesting this one, the data is not available in here, it will request data from the database, and then data will be retrieved from the database, it will be stored in the cache and then written back. So and whenever again that request is coming in again, so for sure that data will be there and it will be written from there. So now whenever the request is coming in, it does not have to search in the huge database which has years of data, terabytes of data. It just have to search in the temporary database. So the benefit that it gives, that response is pretty fast with this storage, with this temporary storage and that cache that we say. So by definition, if say that cache is a temporary storage area that stores the result of frequently accessed data. Now let's discuss about the categories of the cache. Now we get to know about what kind of cache is there. If I have to talk about that, like cache and what other types of cache are there. So there is read through cache, read through cache is there, and another category is there, that is write through. So these two categories of cache are there. How they come into play? So whenever there is any write happening, so the web server will request the database to write that data, and ultimately immediately it will write the data in the temporary storage as well. So write will also happen through cache here. So what will happen in this case? Whenever that data is requested, that data will be read from the cache directly, and there won't be any inconsistency between database on and this cache. The read through, that it, as its name suggests, read through cache, right? So whatever read request is coming in, that will be read from the temporary storage, but whenever any write request is coming in, that write will directly go to the database. Write will not go to the temporary storage. Temporary storage will be filled in whenever there is any read request. So let's say initially our cache or temporary storage is empty. First time that request is coming in, so this arrow will take care of that first time read. It won't be available in there. It will further go to the permanent database here. It will retrieve that data, store that into the temporary cache, and return the result. So first time request will be costly because there is more hops that it has to make, right? But ultimately whenever another same request is coming in, that will be pretty fast, and that is what I want. If I have very heavy read uses application, I will use this application. If my application is very write heavy, so I will use the write through, because there is frequent write happening on the database. I want my storage or temporary storage to be updated all the time, so that I don't have to hit the database again and again. Still, because temporary storage has limit in size, that eviction will happen in this one based on the configuration that we have done. But this is how the read through and write through cache comes into play. So we understood what is cache, what are the different types of cache, and when and which use cases they come into picture. Now coming to the another case, like what kind of this is type of cache, that yet another category I say. I divide it like how we are using this in the server one. So that category also comes in, like first one that we have, that is in memory cache. In memory cache is there is single server cache is there, and also there is third category, that is distributed cache. All right, so just making this arrow in here so that things are pretty much clear. So these are the three categories. So this is one types how it comes into play. This is yet another category that we have types of servers and all those things. So let's see how this comes into picture. So let's say in this, let's understand in this, we will let's understand the concept in this diagram only, then we will try to apply that in here. So web server, now whenever any request is coming from the client, that business logic processing and all those stuff is happening. Wait a minute, so let me draw this arrow. That request is coming, web server is processing that request. So first thing is that I will process that request, get the data from the database, and I can store that information in memory to be used later on, because that's a instance, that physical machines that I have, there is certain amount of memory available there, right? So I can use that storage. So if that data is very short lived, I can store that information in the web server itself and return to the actor, and this will be super fast because I do not have to make any network call to any other server or any other database. All right, it will be just returning from in here. So but this will be very much temporary, and short-lived data should be used for the in-memory cache. If I talk about the example, the session, whenever we have to store the user session information, that can be stored in memory. So that will be super fast and can be useful. This is the one thing. Coming to the second point, that is single server cache. This can be that example when I have a single server to make use of that temporary storage and cache, and whatever request flows that I have explained to you, that will come into play. But the problem in here is that there is a single point of failure on this one. If something goes wrong and it goes down, again web server has to hit the database again. How can I fix this one? So the one benefit is there, that it is going to be pretty fast, but less than in memory, but it is going to be pretty fast, that is for sure. So how can prevent the single point of failure? So the same thing, how we were preventing the single point of failure in case of server, how we were handling this in case of the databases that we had, we were putting multiple copies, right? Multiple copies means that is distributed systems, right? So I can have multiple copies of this temporary storage, that distributed system. So whenever read or write is happening on one instance, one replica, that another replica will be updated asynchronously, and any other web server is coming in, it can read it from any other replica that is available in here, and where load is very limited. That is how distributed cache comes into play, and it prevents the single point of failure. And whenever we have huge system where we are talking about billions of requests and unlimited requests, so this is completely makes sense to have things in a distributed nature, because the user base is throughout the world, right? Anyone can access the things from anywhere. So it's very good idea to have things distributed, prevent the single point of failure, prevent the zero downtime. Okay, that is where it is going to be very important. So I hope you got the understanding about the cache in here. Now let's try to fit in this in this diagram in here. So how can I fit this in? So maybe I can have this rectangle in place. Let me color code it with this one and expand it a bit, and because this is going to come into picture whenever we have database operation, right? So let me put it this way. I will say this. I will call it cache layer. Before interacting with the database, that request has to go through the cache, and it has to go through the cache or not depends on the categories that I have explained. Like there are two things: read through cache, write through cache, in memory cache. So in this diagram, you just visualize that to improve the performance, to improve the latency when interacting with the database, that cache layer is in picture. How it is coming into picture, always come to the bottom and refer to this diagram. You will get the complete understanding about these things, right? So I hope this one was useful for you. Let me see what I can add more around this one. So cache, one disadvantage I would like to add, right, it's not that it's always beneficial, because the more integration points you are adding, there is more chances of failure, so you have to maintain one more layer. So the thing is that I want to improve the user experience, right? So that is why I want to use the cache layer in here. All right, so keep in mind the use cases, and if your database operation is performing pretty much the latency that you need with your to have a very good user experience, there is no need to have a cache layer. Nowadays we have very good NoSQL databases, even RDBMS also, that gives a very good performance in terms of write and read also. So unnecessarily do not use the cache layer. If there is so many operations on the database and it is having like more latency, only then add the cache layer. It's just a fancy name, just for the sake of using it. Do not use it. Consult with business stakeholders whether the current latency without cache is fine or not. If it is fine, go ahead with it. So this is fine. If it is not, then consider using cache with the database that you are using it. So that was the note that I wanted to leave for you guys. So I hope you got the understanding about the cache layer. Let's have this picture, this diagram, and whenever you have any question, anything coming in your mind, put that in comment section. I'll try my best to reply to that one as soon as possible. So I'll see you in the next one. So what is the next topic that is there? Next topic, we have CDN. We are going to see what is this CDN, how it is coming into picture, and how it can help us in improving the latency. So see you in the next video with this topic. Till then, take care. Bye bye.